Back at it. All right, back at it again. Let me get a full screen, see what you're seeing. So we're going to learn another skill here, how to find the derivative of an inverse at a particular x value when you can't actually symbolically find the inverse equation. All right, so what do we do with a problem like that? Well, let me give you a little trick of the trade. Whenever you hit something new and it's complicated, can you work with a situation that is simpler? I'll give you an example of, situation that looks a little complicated at the start. Could you think of a simpler situation? Yeah, textbook tells you what the formula is for difference of two squares, factoring, difference of two squares or the sum of two squares. So what's the situation that's easy? 27 minus 8, those are two squares. I'm sorry, two cubes. Difference of two cubes, sum of two cubes. So 27 minus 8, difference of two cubes. And you got the formula in the book, and you want to see how it works and why it works. So you work with a simpler situation. And so it's about cube roots. It's really about geometry. Forgive the fact that they look the same size. But, a perfect cube, 3 by 3 by 3, which is what that is, 3 cubed, and a 2 by 2 by 2, which is what that is, 8. Right? And the formula is 3 minus 2 times 9 plus 6 plus 4. Where these numbers come from? Obviously, the cube roots for the first parentheses. And that's one dimension. To get back to 3 dimensions, you need the other 2. So you start with a cube root, and the first thing in the next parentheses is that number squared. And it sure looks like the same things happen with the 2. You're squaring it. When you square something, it's positive. Doesn't matter if it's positive or negative. It's going to be positive. So then the question is, can you see the parentheses and figure out a way to get the number 6 out of this parentheses? No, yeah, obviously 3 times 2, and you change the sign. Well, then you're up and running, and then it's just a matter of practice, harder situations. But that's not what we're doing here. We're doing calculus. And so what we're going to look at is a question like, okay, I give you f of x cubed plus 5x, and g of x is the inverse of this. G of x is the inverse of this, and we want to find g prime of 18. That's a problem because you can't find an inverse. You can't write an inverse for this. Yeah, I've been playing with it for years because putting cubics in graphing form, I thought maybe there was a way to do it. I haven't figured it out. Maybe there is, maybe there isn't. If there is, I'm not seeing it. But I played with it, and we'll continue to. So how do we figure something out like this? Well, we go to an easier situation. All right, the easiest situation I can think of is the square root of x and x squared. They're inverses. See if you can see everything here. I hate to move all these desks around. They get mad at me when I start moving. I'll try to move it back to exactly where I did it. All right, yes. All right, so I've got some arrows here that I was playing with. Probably should have just kind of done it from scratch, but I wrote everything out, maybe speed things up because I'm heading up to Keene soon. So y equals x squared. We should be familiar with that a 3 gets us a 9, and the derivative of x squared is 2x. So at x equals 3, we have a 6-to-1 ratio of change at this instant. So if you looked at table values, the 3 to 3.001, the 9 to 9.006, when we did that work, it's going up at 6-to-1. The inverse of 3 to 9 is 9 to 3. And if you take the derivative of y equals the square root of x, it's 1 over 2 root x. And if we drop a 9 in there, yeah, we get 1/6. 3, 9, 6-to-1, 9 to 3, 1 to 6. Layering a little bit more concept here. 6 is a representation of y2 minus y1 over x2 minus x1. Keep my finger there. Now, algebra 2, algebra 1, pre-calculus, somewhere in there, you should have learned how to write an inverse. And I like to start with it at algebra 1. What do? Change the x's and the y's and solve for y. Well, what happens if I change the x's and the y's here? All of a sudden, I get x2 minus x1 over y2 minus y1, and that's actually the reciprocal of 6 over 1. It's y. It's 1 over 6. Okay? So now these get a complicated in the textbook form. 1 over f prime of y, whatever, g prime. It's a kind of complicated form. So the issue is, can we just simplify it and know how to do it? All right, and then if you want to get technical, get into the textbook, look at the formula, and you'll sort it out. I'm not asking you to do that. I want you to make a connection here. Okay, so how could I have taken this, need an eraser, gonna get one. How could I have taken this and gotten it down to the original question that I asked, which is where all I have is that these are inverses. So I'm going to call this f of x. And I'm going to call this g of x. And I'm going to say they're inverses. And I'm not going to give you this. And I'm not going to give you this. And I'm not going to give you anything other than, can you find g prime of 9? And then you really got to be able to fill in all the information from there. Well, this is an input. What's the inverse of an input? An output. There's an output. So we look at that and we go 3 and negative 3, but let's just take it with the side that we were working with. Oh, I can see that f of 3 equals 9. And since we have this function, I know what the derivative of x squared is. The derivative is of x squared is 2x. Oh, and I know that 2 times 3 is 6 to 1. Well, then I know that over here, g of 9 gets me 3. And over here, I know that f of 3 gets me 9. And I know that f prime of 3 gets me 6 to 1. Then over here, I now know that g prime of 9 gets me 1 to 6. Okay? Now, I'm hoping we can do that a little quicker than I have with other classes before, because I think I may have just presented it a little differently than I have in the past. And I hope it's helpful. That's my hope. All right, but we'll do a couple of problems here. I hope I recorded here. Yeah, it should be. All right, so here we are. I'm trying to find g prime of 18. All right, that's the input over here, which means it's the output over here. Now, what number gets us 18? And these are not going to be done with algebra. These are going to be done with counting on your fingers. These types of problems. Just counting on your fingers to see the relationship. And so you're looking at numbers, maybe 10, maybe 5, maybe 3, 2, 1, maybe negative 10, negative 5, negative 2, 3, things like that. We're not really going to throw tough numbers at you. All right, so you look at that and you go, oh, let's try 1. Oh, not big enough. How about 2? 8 plus 10. Oh, I now know that f of 2 equals 18. Well, that means that g of 18 equals 2. Did you see that? Yes. All right, now I guess we'll find f prime. F prime, let's get f prime of x first, which is 3x squared plus 5. And then let's find f prime of 2, which is equal to 12 plus 5 is 17 to 1. Anybody want to guess what g prime of 18 is? If you said 1 over 17, then you're already doing that problem right. So we're going to practice these. Usually folks get the hang of this pretty quickly, so I'm not going to do too many. Do another now. We'll pick it up in the first week of homeworks coming back from midterm. All right, I'm betting that by this, you're going to look at this for homework Sunday night, I hope, briefly. I'm hoping by Friday you're knocking it out of the park. Don't forget to follow all the way through when you swing. Okay? If you ever teach anybody baseball, hit back at the pitcher, follow all the way through. There you go. All right. I don't know about cricket. Probably something similar. No, you don't want to hit it back at the pitcher because you're trying not to get out. It's all about timing. All right. So let's do a problem here. Let's say that I give you f of x equals I don't know, x cubed plus 9x, similar kind of problem. All right, and over here, we're trying to find g prime of, let's see, what would be a nice number? Minus 26. Minus 26. Okay, so you come over here and you go, oh, that's the input over here. That means it's the output over here. So I know I got a number that's negative. And you first start with 0 and -1 and -2 and -10, all that stuff. And I hope you land on the fact that f of -2 actually gets me, I hope I did it right, minus 18, minus 8. Yeah, 18 and 8, 26. Brain's slowing down here. All right. And so that tells me that over here, g of minus 26 equals 2, -2. We don't really care about that, but it's true. We're really only after this. So I can take that derivative. F prime of x is 3x squared plus 9. Very similar to the last problem, I guess. So what's f prime of -2? Well, that's positive 12 plus 9. Looks like it's 21. So 21 to 1 over here. Switch the x's and the y's. Remember, when you do inverses, switch the x's and the y's. So reciprocal. 1 over 26. Okay, so we'll be banging that out of the park, I hope, by next Friday as a class. I'm hoping some folks can bang it out of the park on Monday. If you watch the video and think about it, I think it's pretty straightforward. So of the 5 things we have to do, taking the derivative of arcsine, arctan, will be, I think, pretty perfunctory, one of our words of the day, as will this problem, once we get a little practice in. Okay, next video I make, volumes. That's a biggie. Yeah, that one throws folks for quite a while. Yeah, but I'm not grading you again for quite a while. So I think what we'll do is try to front load our worksheets during this next week back with the newest topics and working through them, and then hopefully mix it all up going forward. By the end of the term, I hope you're pretty functional with a lot of the topics, and that you're starting to garner a nascent, that's a good word of the day. Our new word of the day is nascent, N-A-S-C-E-N-T, nascent, and that's an emerging understanding of this discipline at this level. Okay? Not only emerging, but actually sound. All right. See you on Monday, I hope, God willing, if you believe in God.